In a world that requires so much attention and concentration, there's medications that allow millions of people to gain control of their lives. One medication that I am connected to is lisdexamfetamine, aka Vyvanse. This medication allows me to take control of my ADHD and allows me to better my focus. To understand Vyvanse, we need to understand the chemical structure. The name of Vyvanse is 2S26-diamino N1S 1-methyl 2-phenylethyl hexamonide, which I have drawn over here. So right here we see lisdexamfetamine. Here is lysine and diamphetamine, which we'll talk about later. And here's an amide bond. The 1S and the 2S comes from this point and this point. This rotates here, and this rotates here, which is both counterclockwise, which means left, and in chemistry, left means sinister, which is S. The more condensed version is C15H25N3O, and it has a weight of 263.37 grams per mole. The pharmacology profile of Vyvanse is what makes it so valuable, and according to a research project from Najib and her colleagues, it undergoes a biochemical conversion following administration of its active form diamphetamine, which is shown over here. This is what allows it to be a stimulant because it has a release of norepinephrine and dopamines. This also allows, according to Dolder, Patrick, and their colleagues, diamphetamine prolongs pharmacokinetic profile, and it is considered to be associated with slower effects on dopamine release and lower euphoric effects, which is major when it comes to ADHD medications because it's a medication that's super effective, but it's also not super addictive, which is unlike a lot of the other ADHD meds that are out there. Um, Lisdexamfetamine works so well because of its huge release of dopamine and norepinephrine, and this is due to the diamphetamine that I was speaking about earlier. And Pinnock says that dextroamphetamine ultimately blocks the reuptake of norepinephrine and dopamine into presynaptic neuron and increase catecholamine availability in the extracellular space, which is going to be speak about later because it involves a bunch of different reactions. This reaction starts with the um, taking it orally, taking the medication orally. There's tabs and there is pills, and then it goes through the small intestine. It goes through the small intestine because it's the best place for absorption, thanks to the villi and the microvilli, which increases the surface area of the small intestine. And then after it is absorbed, it goes to the liver, and in the liver there is it is absorbed by the enzymes, which is called alanine phenylene lyase, which pushes the bonds between L-lysine and diamphetamine, which begins the breakdown of the molecule. And this results in the full absorption of the drug to finalize and release diamphetamine and lysine into the body. So practically, this enzyme breaks these two bonds, separating it, leaving us with the active drug and the L-lysine. And in conclusion, Vyvanse is a drug that allows millions of people to take controls of their lives to fight ADHD, and I find it important to understand the chemical makeup of these medications that benefit so many lives. As the world continues to grow, so will mental illnesses, and I find it important to be informed on medications. And I hope that my chemical breakdown of lisdexamfetamine informs you of this drug, but I also hope it sparks interest in doing research on your own of medicines you take or any other type of medications, because it is important to understand how medications work because as I said, as time goes, mental illnesses will continue to come up, and it can even get to the point where humans build up intolerance to medications or build up tolerance to medications. So it is important to understand how the drugs work so that we can find solutions instead of sitting back not knowing what's going on. But thank you for your time.